The James Webb Space Telescope was successful in beating its record for the farthest distant galaxy that has ever been observed from Earth. Prepare to be shocked as you watch this video that explains how the supernova discoveries made by the James Webb Space Telescope have stunned the entire globe. Let's get started. Now, before we dive in, we want to look at some comparisons between the James Webb Telescope and the Hubble telescope. The James Webb Space Telescope has several benefits that are unavailable to the Hubble Space Telescope. Webb travels around the Earth at a distance of approximately 1.5 million kilometers, which is almost 4 times greater than the distance between the Earth and the Moon. The photos taken by the Hubble telescope, which is approximately 547 kilometers away from Earth, are susceptible to being influenced by space stations and satellites. When it comes to performing observations, the Hubble telescope concentrates the majority of its attention on the visible and ultraviolet spectrums of light. Both the NIRCam, which is designed for viewing in the near-infrared spectrum, and the MIRI, which is designed to observe in the near-infrared band, are included in the instrumentation of the James Webb Space Telescope, which gives the James Webb Space Telescope more clarity in its image capture. The James Webb Space Telescope was able to make out the shape of a bumblebee as it flew above the surface of the planet Earth from its vantage point in orbit. The infrared vision of the telescope enables it to stare at the edge of the universe, where some of the oldest stars and galaxies in the universe can be found. The Hubble Space Telescope is unable to see through the thick layer of gas and dust that encircle many planets, stars, and galaxies. On the other hand, the James Webb Space Telescope is analogous to an X-ray and can see through anything. The James Webb Space Telescope includes a mirror with a diameter of 6.5 meters, which is one of the most defining qualities of this instrument. It can take in a great lot more light than any other mirror that has ever been sent into space, and it is the largest mirror that has ever been put into space. When compared to the size of this object, the mirror on Hubble, which has a diameter of 2.4 meters, appears to be a speck in the distance. Why is this even important? The supernova discovery made by the James Webb Telescope has the entire world in a state of shock. The scientific mission of the James Webb Telescope will collect atmospheric spectra from exosolar planets and beyond. This will be done in addition to the hunt for galaxies at the edge of the observable universe. A prime example of this is the study of supernovae, which is an extremely important task for cosmologists and astrophysicists to work on. Observation of supernovae, which can give information on both the mechanism by which massive stars die and the process by which heavy elements are produced, have helped to improve our understanding of both processes. In addition, astronomers use supernovae as a standard candle in the calculations that they use to determine the distances between galaxies. This helps them determine how far apart the galaxies are. It is possible that the James Webb Space Telescope, which is equipped with more sophisticated instruments, will be able to produce exact measurements of the supernova's brightness and give clarity to the existing astronomical distance scale. As a direct result of this, it is now feasible to ascertain the rate at which the universe is expanding with a degree of precision that was not achievable in the past. As we move forward, let's look at some of the surprising findings that were uncovered by the James Webb Space Telescope. The James Webb Space Telescope made an unexpected finding of its first supernova, which is the explosion of a dead star. This discovery has taken scientists by surprise and caused them to be taken aback. Scientists believe that the discovery may have the capability of introducing entirely new avenues of inquiry into the realm of possibility. Only a few days after the beginning of its science operations, the NIRCam camera aboard the James Webb Space Telescope made a startling discovery and found a very bright object. The item was found in a galaxy known as SDSS.J141931.11+5251593 and was many light years away from Earth at the time it was discovered. The bright object's slow dimming over 5 days gives evidence that it may have been a supernova that was detected by total and utter chance shortly after the star erupted. For the researchers to determine whether or not the light in question was indeed brand new, they compared the data from the most recent observation with data that has been gathered from the Hubble Space Telescope in the past. The James Webb Space Telescope wasn't designed to look for supernovas, which is a job that was typically done by large-scale survey telescopes that can scan enormous regions of the sky at short intervals. Because of this, the discovery comes as a bit of a surprise. On the other hand, Webb focuses its attention on an extremely limited region of the universe and examines it in exquisite detail. For instance, the deep field photograph that was disclosed by Joe Biden, the President of the United States, in the middle of July 2022, covered an area that was approximately the size of a grain of sand. Astronomers believe that the depth of Webb's image may compensate for the modest surface area of the telescope when it comes to Webb's scientific activities. This is something that Webb has said publicly. As a result of the fact that every deep field image contains hundreds of galaxies, there are hundreds of opportunities to find a supernova inside each image. The early detection, as reported by Inverse, opens the potential that the telescopes may be able to observe supernovas consistently in the future. That would be interesting to think about, especially taking into consideration the fact that it is expected that Webb would be able to observe the earliest galaxies in the cosmos as they formed. Webb may be able to capture the explosion of one of the first-generation stars that lighted up the universe after the early dark ages if it combines this old vision with its unexpected identification of a supernova. These first-generation stars were responsible for lighting up the universe after the early dark ages. From the perspective of astronomers, the chemical composition of these stars was noticeably simpler when compared to that of stars that were born in subsequent epochs. In a conversation with Inverse, Mike Gesser, an astronomer working at the Space Telescope Science Institute, which is the organization that runs Webb and was the leader of the team that reported the detection, discussed it. Mike Gesser said, "As opposed to the types of stars that exist now, we think that stars in the first few years would have large, almost exclusively been made of hydrogen and helium. They would have been enormous, having a mass that was 200 to 300 times that of our Sun, and they would have undoubtedly followed a live fast, die young kind of lifestyle. Explosions like these are something that we haven't truly witnessed up close and personal yet." The discovery of a supernova suggests that the death of a much younger star, one that was only many years old, but it is a promising start for a telescope that was designed to achieve something completely different from what it has so far accomplished. Finding a supernova can be difficult because the explosion that generates one lasts for only a fraction of a second, making them hard to detect in time for observation. To observe a supernova, a telescope needs to be aimed in the right direction at the appropriate time. This is because the dazzling bubble of dust and gas that these supernovae form disappears within only a few days. Astronomers must now cross their fingers and hope that Webb's first supernova was not an accident.